Thank you for joining me again. We've spoken about some major aspects of probability, the experimental probability and the theoretical probability, the rules, the addition rule, the multiplication rule. Under your addition rule, we spoke of mutually exclusive and non-mutually exclusive, and under the multiplication, we spoke of the dependent and non-independent events. Now we talk about the problems that we can solve under probability. And under this, I will want to make use of the tree diagram. So let's solve the following questions quickly. Look at this, how to draw a tree diagram. If you have something like this, I have two coins being thrown, two coins. So of course, you will have one of the coins will give me head, the other one will give me tail. So how many throws do I have? This is the first throw, and this is the second throw. So if I have the first and second throw, and how do you know the number of outcomes? It is by 2 raised to power of n. So these two outcomes now. What do we have? 2 throw, Abi? That is 2 raised to power 4. Yes. 2 coin, 2 throws, 2 raised to power 4. That's 2 raised to power 4. That is what? 16. What do we have here? Okay. 2 raised to power 2. So this will be 2 raised to power of 3. Let me clean this. I have 2 raised to power 3. So that will give you 8. 1, 2, 3, 4, 5, 6, 7, 8. The total outcome is 8. But that aside, let's solve these questions that we have on the board. So we start with question 3. Start with question 3. I want to make use, okay, I will have to draw another one, another tree diagram for that purpose. But under that question, we have the following. Look at them critically. So we have this. A die and 2 coins are thrown together at once. What is the probability of getting an odd number as well as a tail and a head? What that question means, probability of getting a coin, probability of getting one odd number, and that will be from the die, and getting odd number and tail and head, th. So this one, what do you call this? This is under your multiplication rule. And you look at this, is this a dependent or independent event? It is. They are mutually, how can I put that? This is a dependent event. It's not independent. Oh, sorry, independent event. The occurrence of one does not affect the other ones. So it is not, it's independent. So what do we do now? Then it means we go odd. In a thrown die, how do you obtain an odd number? So for odd probability, let me take that as probability of O of 0. Let me use 0 to avoid stories. Let's take a probability of A for odd numbers. How many odd numbers we have in a thrown die? We have 1, 3. Okay, let me write that out. I'm taking it as A anyway. So A, in set A, we have 1, 3, and we have 5. So probability of A should be equal to 3 upon 6, and that will be 1 over 2. Now for the tail head, let's use our tree diagram. If you have a die and two coins, so one will be tail, one will have head. You can have head and tail, it can go any of them. So it's thrown, just a thrown. So this one will produce a tail and a head, and this one will produce either a tail too or a head. So our space, what will we have? We are going to be having T, or we have T, H, and we have HT, or we have HH. That is head, head. Then we have tail, tail, head, tail, or head. So now the question is probability of getting a tail and a head. A tail and a head. There's a tail and a head here. There's a head and a tail. It's a tail and a head. So we have 2 upon 4. That will be 2. So that will be 2 upon 4. And that is 2 here 1, 2 here 2. So I can say the probability. Sorry, let me wipe this. Probability of getting a odd number. Probability of getting a odd number. Probability of A intersect B will be equal to, where B is probability of getting a tail and a head, that will be 1 upon 2 times 1 upon 2, and everything will be what? 1 over 4. So that is sorted. The next question. The question 1 now. We go by question 1. Question 1 says that you have some of these things here. The probability that the farmer and the hunter will be alive. Okay. Will be alive in 10 years' time is 0.5 and 0.4 respectively. So let's take the probability that the farmer, that is probability of F, will be equal to what? 0.5. And the probability of the hunter being alive, the probability of H, that is, take that 0.4. They give you in percentage, you express it back in decimal. Yes, it's possible they give you that. Now, what's the probability that one of them will be dead before the 10 years? We've been told that the probability that a farmer will be alive will be 0.5. The probability that the hunter will be alive is 0.4. Now, what's the probability that one of them, what's the probability that one of them will be dead before 10 years? So how do we get that? This is use of addition rule. So two things will happen. It's either one is alive, probability of one is alive, and one is dead. So we are combining both addition rule and multiplication rule. We have probability of one alive and the other dead, or the reverse can happen, that the one that was alive before will be dead, then the other one will be alive. So what does that mean? We need to look for probability of F prime, which is being dead. And that will be 1. Okay, let me still write that down so that we now have storage that touches the earth. Probability of F prime. What would that be? 1 minus 0.5, and that is still 0.5. then probability of H prime, the probability that the hunter dies, that will be 1 minus 0.4, and that will be equal to what? 0.6. So now calculating a probability of one will be dead before the 10 years time. So we go by probability of F times probability probability of the farmer being alive, or probability of the hunter being dead, or that's plus, or probability of the farmer himself being dead, and probability of the hunter being alive. So we have what? Probability of him being alive, we have 0.5 times 0.6 plus being dead 0.5 times the hunter being alive is 0.4. So what do we have? 0.5 times 0.6, 0.5 times 0.6, we have 0.3 plus 0.5 times 0.4, that will give you 0.2. So both of them will give you 0.5. Now this is the answer to the question. The probability of one of them not seeing or not living up to 10 years. These are the two things that can happen. Either one is alive, one is dead. One is alive and one is dead, or the former is dead and the latter is alive. It's as good as that. So we go to the next question before I wrap this up. Okay, we have a question. Under this question, we have it that the probability, okay, in a class, this is a different question. It's a different question. In a class, okay, don't forget we are treating problems on probability. So there are diverse questions. The question says, in a class of 80 students, 40 are studying geography, 30 are studying mathematics, while 10 are studying both. Find the probability that a student choosing at random is studying none of the subjects. Wow, this is a set problem leading to probability. So let's do from our set theory. I've treated some videos on set. You can revisit them if you don't know how to work with this. So we have, let's use a Venn diagram. You have this. There's an intersection. Okay, let me make it bigger. So the universal set said there are 80 students in the school, and for geography, 40 studying geography, and 30 studying mathematics. Now this will be those studying the boats. They said how many 10 study the boats. Then those that are not studying any of them, this will be X here. Yes. So what do we have? This one will be 40 minus 10. This one will be 30 minus 10. What do we have? So we're going to be having 30. For those studying geography only, 30. Those studying the 2 plus 10. Plus those studying mathematics only, 20. Plus those not studying at all. Everything should be equal to that number of students we have in the school. Or in the class. We have 80 students in the class. So 30 plus 10, 40 plus this 60 plus X will be equal to 80. Then your X will be 20. So since X is 20, the question is, so if we want to get X, the probability of those that do not study any of them, probability of those that's probability of X. X is people that do not study at all. That not study any of those subjects should be 20 upon total number of students in the class, that is 80. That's 1/4. The question says, find the probability that a student chosen at random is studying none of the subject. So we have 1/4. And probability of X occurring, probability of having a student that has been picked and is studying none of the subject. Since you first calculate for the number of students that are not studying that subject, then you have that as good as done. Thank you for joining me. See you again later.